Thank you. I'm very excited to be here at Camblaze, to be sharing some of the research that we've done in my team. Just making sure folks can hear me loud and clear. Excellent. Great. So hello, my name is Gary. I'm a principal at Microsoft. A lot of my work deals with right now breaking things and building environments in which we can automate a lot of these kind of like attack and defense scenarios. So this is some of the research that some folks at my team have done, Mauricio and Manny, on this agentic framework. Cool. So I just want to give a quick overview, right? So there's some limitations when it comes to traditional like security testing, right? So if you have like something like Kali Linux, you're doing things manually, but obviously with large language models and generative AI, now there's this huge opportunity to automate a lot of those attacks. So what we are going to be discussing today is sort of like our approach to building these simulations. And I will give you some tips for how, if you're trying to build this, some tips on how you can go about and implement your sort of like own version of this. So I love building things. So I'm going to start with the kind of like the system architecture, how I went about selecting some of the different large language models that can power these agents. Then I'll talk about how the execution frameworks work, and then some of the blue teaming and red teaming applications. Right. So like I was mentioning earlier, if you're using something like Kali Linux, if you're using tools that are manual, everything that tends to be sort of like scripted, very static. We want to start to use Gen AI to really run this at scale. Right now, it's very limited in scope. So we want to start to be able to use agents to sort of like run things more autonomously, explore new TTPs. So something that we have a lot of emphasis in our team is, can we build these agents that can come up with novel solutions and autonomously identify attack paths that we haven't previously seen, so then we can sort of like let them run loose in our environments and identify novel failure modes. So there's poor training data sets that we want to sort of like improve. And right now, manual testing tends to be sort of like very resource intensive. So we want to leverage AI as much as we can here to create these dynamic, realistic adversarial environments so that we can sort of like have AIs running in those environments. So this is kind of like our approach. So there's this LLM power planner. We have this human in the loop component that I'll describe in a little bit as well. Then so it sort of like executes attacks on its own. We let it loose in the environments that we create, and then we can generate high fidelity telemetry. So to give you a little bit of background, so our team has three main pillars, right? So the overarching goal is we want to improve the security of our systems. So we do this by having a red team. So we have folks in the team building autonomous agents to attack infrastructure. So in our case, we're attacking Microsoft infrastructure. Then we have a blue team whose whole point is they want to build agents to try to catch the red agents. And then my team, we're focused on the environment, right? So where are we going to put these agents to sort of like do the wargaming, to do the interactions? So this particular piece of research that I'm showing here deals with how do we build these high fidelity environments where we can put both the blue and the red team agents and have them interacting with each other. So from a high level overview, this is how it looks like. A couple of things that I want to notice, right? So we have, I think as we developed AI systems, it's very important to have this human in the loop component. So this is something that is sort of like baked in from the very beginning. So so we have sort of two planes. So on the right, we have the human control area. On the left, we have this like agent control, like fully autonomous bit of the system. So the way it works is that there's a prompt, right? So we will tell our agent, something like, I want you to create an environment that has 5 virtual machines, has all of these different resources, is connected like this, and I want you to just sort of like deploy it automatically and verify that there are some vulnerabilities here. So the way it will work is it goes to a planner. It will draft some sort of attack plan for how we can go about generating that environment. It will do some verification, because we're building simulations to ensure that the red team folks can hack the systems. We spend a lot of time trying to verify that there are vulnerabilities reachable within the simulations that we're building. So if you can imagine of any sort of like cloud-based attacks, we want to make sure, for example, that a specific virtual machine perhaps is able to reach a secret or a key that can be then exfiltrated to then get some sort of like privileged access to another resource that then can be used to do something like email exfiltration. So all of those things happen within this attack draft planning. We do the finalization of the attack to make sure that it's valid and traversable by the agent. Then it goes back to the planner. We get approval from the user to make sure that the things that we're deploying should indeed be deployed. We kind of like explicitly consent for the deployment, and then it goes to the final orchestrator that then does the deployment of the infrastructure. It will execute the actions to make sure that things are traversable, that then we can get the telemetry and the metadata to fine tune the agents or some other solutions down the line. And then we, like I mentioned, we do the telemetry collection. So a few tips that I want to mention. I know that, right, everybody's sort of like building agents using large language models. I've seen that it's very common for teams to sort of like build agents, like tons of different agents, right? It has been my experience as sort of like a tip as you develop these agents that having, fewer agents tends to help a lot, at least at the very beginning, because it's way more easy to kind of like manage a small fleet of agents than like hundreds of thousands of different agents. So in these specific sort of like architectures, there's two main sort of like AI brains, if you will. Use the planner that does all of the drafting of the attack and creation of the attack, and then the orchestrator. So just two agents are in charge of sort of like orchestrating the whole thing and making sure that things are sort of like up and running. Cool. So I've already mentioned the human in the loop component, but this is an example of what the prompt for the model, what the prompt for the agent will look like at the very beginning. So you can say something like simulate a password spread followed by lateral movement. All right, so that will go into the first agent. It will create an environment that will satisfy these constraints. And then the user will sort of like manually give it approval to generate and deploy all of those different resources. Now, the interesting bit with the human in the loop component is that if you don't like something about the resources that it's creating or the things it's deploying in Azure, then you can explicitly ask the model to refine the resources and the things that it's deploying on the cloud, right? So again, by having this human in the loop component, you can incorporate feedback, and then you can deploy things that are sort of like align with what you're expecting. And also, when you're running commands that can be kind of like dangerous in the environment, it allows us to have, again, explicit consent to make sure that we're not performing destructive actions, or if we are doing those, that we have explicitly approved them. Right, again, so this is the planner here on the top. The key bit here is that it kind of like translate the objectives, such as I want an environment that you can use. I want an environment that is sort of like vulnerable to some sort of password spray, and then there's some lateral movement, and then some resources that I can exfiltrate. So that's what the planner is doing, and all it's mapping all of these to available APIs. For example, from Azure Graph or ARM or Terraform or whatever that might be, to be able to create these environments. The second bit is the orchestrator, right? So we have some in-house tooling to be able to do the deployment of the infrastructure. So one of my coworkers has created a tool called Bad Azure. So if you go into GitHub, you're going to be able to pull that code, and that is sort of like one of the bits that we're using for this orchestrator to like deploy this environment. Then we also have some tooling to do the actions, right? So we've created this environment. We want to validate that you can indeed traverse the attack path, so that the red team agent comes later and is able to exfiltrate data or do whatever objective we're trying to do. So the orchestrator has APIs that can ensure that that indeed is traversable and exploitable. And then we have more tooling that once all of these resources have been deployed, and once the attacker is sort of like traversing the environment, we're able to collect all of that telemetry in the hopes of making the blue agent better down the line. Right. So there's when I was creating this sort of like planner agent, I was playing with multiple different language models. So Grok, DeepSeek, the GPT series of models. And just sort of like a small tip, it has been my experience that using models like Grok and DeepSeek tend to be quite good at creating sort of like very malicious plans. Things like GPTs, the GPT series of models will kind of like refuse creating those plans. That that could be a good thing, right? But again, for the use case that we have here, we want to use models that are like very permissible to creating like clearly malicious environments and actions. Again, so if you're creating these sort of like agents, just try to keep that in mind, right? So yeah, GPT o3 Mini, the 5 series of models are very good at not generating any of this. So this is just an example. Couple different scenarios that we try to generate these environments for. So the kind of the typical example that we use in the team is the data exfiltration, right? So if you're using something like GPT-4o Mini, GPT-o3, 5, it will like basically always tend to refuse to create environments to do that, and it will always refuse to sort of like traverse the paths to attack the environments. So this is where Grok and the DeepSeek series of models are really good at creating these agents. If we're trying to create environments where it's possible for an adversary to have like deep persistence in the system, sort of like stay dormant for the like longer campaigns that we are creating. Again, we see this sort of like the same pattern where Grok 3 and DeepSeek work quite well, but the other models tend to fail. I did notice that for some of the clearly malicious examples like generate environments and generate code and malware on the fly, all of the models tend to refuse that. But again, there are ways in which that can be bypassed. But I did notice that asking those things explicitly tends to be refused kind of like directly. Yes. So another note on the kind of the orchestrator that we have. So because we're trying to sort of create campaigns that are highly realistic to what you will see in the environment, we rely on Azure Functions a lot. And the reason why we did that is because if you have something like a password spray, a nation state or like adversaries won't typically come out of a single IP, right? They will sort of like geographically distribute their attacks to make sure that they're sort of like blending in the background. So if you're looking into creating sort of like these applications or these agents to sort of like mimic real world attacks, I would encourage you to try to do something like this as well. So I think this is a good pattern for this because we deployed our resources so like across multiple regions, and then we're able to come out of multiple nodes and sort of like blend in the background and make it way harder for the blue agent that we're also developing to catch our attacks. Now, another of the things that I want to highlight here is that as you build these systems, you can sort of like execute everything at once, but we're also trying to build the orchestrator and the planner in such a way that these attacks can take sort of like a long time, like days, weeks. Ideally, we want to get into like the months time frame where these attacks happen slowly. They are in the background, they blend with the noise, and again, it makes it way harder for the blue agents that we are developing to catch them, right? But the idea is that we can use all this data to train better blue models to help us catch some of these longer running campaigns. So yeah, so we are things like asynchronous execution, jitter, things like that. So again, with this sort of approach that we're taking when we have this planner, we try to map as many things as possible to sort of like the MITRE attack techniques, right? So again, so yeah, so this is something that we try to do because it makes things a little bit more like kind of explainable when we create sort of like our reports for leadership of, hey, this is the campaign that we emulated. This is how we created variations on top of that. And this is sort of like the success rate that the red team agent had, the blue agent had when it comes to kind of like identifying the different patterns here. So these are some examples of the kind of the atomic actions that we are trying to create for our campaigns. So if you're using something like Graph, like Azure Graph, there's like different APIs that they have. So we try to wrap all of that so that we can execute something like, run a password spray, right? So and then we can configure that so that it looks like we're running a password spray, or we can sort of like covertly add key vaults to a secret. Secrets to a key vault. We want to do some of the enumeration, like list available resource groups for this specific user, or there's different ways in which we can do the email exfiltration. For example, you can use Graph APIs. For some folks that use like Azure, there's something called EWS. So we sort of have support for multiple types of API to do this sort of like covert email exfiltration. And then for the blue scenarios, right, we're trying to do like model, how adversaries will do the data exfiltration, or we're still trying to figure out, how do we model these like persistence in the systems. And going back to the slide I had earlier, where models tend to refuse to generate malware directly. It was when we were running some experiments for how to simulate persistence in a system, because we're actually trying to like drop files in a system or like overwrite files to make sure that we can always go back to the environment later and be able to get a full hold there. So those are the different things that we're doing for the the malware behavior as well. Because again, the idea is we want to generate environments that are or as realistic as possible. We're partnering with like multiple groups like inside of Microsoft to see and understand, what are different threat actors doing in the wild and how we can replicate those for the red and blue wargaming that we're doing in the team. So right now, I was mentioning that we're focused on these two agents. Another area of research we're actively working is how can we coordinate like multiple attacks happening at the same time. Right now, I would say that it's been my experience that the red team agents tend to win quite often. So that's why we're perhaps not putting a ton of emphasis on this right now. But we are thinking on what would happen, or how can we model like multiple attacks in a single tenant, and see how that would affect the detection rate by the blue agents that we're also building. We're trying to model like real APT behavior. So we are constantly going online and seeing what folks are doing in this space, creating environments that replicate all of those environments, and then trying to deploy them. Again, I had alluded to this earlier, but right now our operations take like hours. So some of the campaigns that we're running take anywhere between 2 and 8 hours, for example. But we're actively working to run campaigns that take like days, weeks and months to run and execute, because those tend to be more realistic and resemble what we see in the wild right now. Awesome. Thank you.
Really great talk. I really like that you used local models as well. A lot of the attack talks I've seen have only used the state-of-the-art hosted models. One of the questions I had was, have you experimented at all with having an initial agent doing any fingerprinting? So seeing, is it ASP, is it React, what's running, and then adjusting attacks based on that.
Great, great point. I appreciate the question. So I would say that right now, how to say this? The blue agents tend to be quite behind, right? So we don't do a lot of emphasis on that. The way in which we usually start is we will hard code initial access for the autonomous red agent to get into the system. So it will know, hey, this is what you have to do. And then at the very beginning, we have different ways in which we run this. We give them hints. So I'm building these war game environments where there's multiple flags. So then the agent will get rewarded as it progresses the system, and then it can use that as signals for the enumeration, and has the agent seen all of the resources available to that, etc. And then we can we're also working towards tuning the difficulty so that then the red team agent is completely blind to anything in the environment, and it has to do everything from scratch. So actively working on that, but yeah, great question. Thank you. Did that help? Awesome. Thank you.
Hi, great talk. I have a question. Like, I was curious about your model selection for like attack plan strategies. Like, use DeepSeek and Grok. How about have you like thought of using some kind of unaligned or models without like guardrails? Given the hypothesis, like these models with less safety layers that they're trained on, like tend to produce more adversarial attacks. Plans or strategies.
A great point. That I would say that is something that we are so like actively investigating. That's why we were looking at like DeepSeek, the Grok models. We're also potentially looking into like fine tuning like our own models for like the simulation bit. So for the blue teaming, yes, we are fine tuning. For the red team, yes, those folks are fine tuning models. But we also want to look at like fine tuning our own models for the simulation bit for like creating things, creating the malware, etc. So yeah, actively researching that.
Thank you.
Yeah, of course.
You go next. Hi, Gary. Great work. We worked on something really similar, and we used Claude 3.7 Sonnet, which also performed really well in case you're looking for. I have primarily two questions. First is, if you don't mind, I would love to look at the system prompt that you guys have used for the head component for creating the attack plans. And the second question was, when we were testing ourselves, we found an issue of hallucinating the attack.
So great points. Like starting from your second question on, how do we deal with the hallucinations? Effectively two approaches, right? So the first one is we try to inject as much context as possible that is relevant to the task. So when, for example, instead of using like raw, if you will, like Azure libraries to be able to generate the attacks, we have some like in-house wrappers that make like more like atomic actions, so that the action space of things that are available to the agent are a little bit smaller, with the hopes of trying to like minimize the likelihood of hallucinations. So that's the first step. And then on top of that, right, I think I showed that in the diagram earlier. One of the, let's see if I can go back here. 1 second. One more, right? Cool. So right here, when we do the draft attack plan, that's where we will see like all of the hallucinations, if you will. When we do the final attack plan, that is after we've verified all of the calls to make sure that they are indeed real, that they would execute in the environment, and that is sort of like the second approach that we take to kind of like minimize the likelihood of hallucination, and again try to prevent they still happen, but try to minimize the number of like runtime errors that we would get as we execute these plans. Was that? Oh yes. See me after this. We can chat. Yeah, I don't know if we can like release the whole thing. I mentioned it earlier. My coworker Mauricio, he's developed Sure, and that one does have some of the components that we are reusing. But for the other ones, I can give you some pointers. I'm not sure that we can release like the whole system. People will get mad at me.
Gary, thank you so much for your presentation. It was a great presentation. So I have a question. Have you ever done any experiment regarding the collaborative multi-agent threats, multiple attacks at the same time, as I think it will be the future direction of adversarial attacks in the agentic AI system?
I appreciate it. Yeah, it's a great point. I would say that is something that we are actively investigating, and that is sort of like part of the future work that we're trying to model here. So yes, we're actively looking into that. There's a lot of like subtleties and like nuances when it comes to like orchestrating this, but yes, we're actively looking into that. Yeah, great point. Thank you.
Do you have a paper on this coming out?
So I appreciate the question. So we've released Bachelor. So that's what one of the research that I'm working with here at Mauricio has done. I think down the line, we are potentially working on a paper. So it's not quite there just yet, perhaps in the future. So I was part of the team that created Pirate. So ideally, I would love to be able to work with my team to see if we could also open source a version of this. Yeah, of course.
Yeah, I was wondering if you ever had your Azure account locked down because of the problems that you sent. And I'm asking for a friend.
Yes, and not just in the context of this. A lot of the work that I do with chem and bio risks, we have this kind of like rite of passage where we all get all our like Claude and like OpenAI accounts banned. So yes, we have had that happen. Yes.
That one, a round of applause for